To read chapter 4 of the book Stuff, Fortunes, Foibles, and Fiascos of Those Who Sought to Understand Matter. Chapter 4 is entitled Galileo, or How to Annoy the Pope. Just so no one gets upset, this chapter isn't about religion getting it wrong, it's about science getting it right. Galileo's story is one of the best examples of scientific findings messing with strongly held beliefs. Throughout history, many other groups of people have tried to defend a view of the world that science had known to be just plain wrong. In this case, it happened to be the leaders of the Catholic Church who weren't able to admit that some of their ideas were incorrect. Here is a picture of Galileo. Galilei was one smart cookie. Most people just call him Galileo for short, as if they were such good buddies of his that they were on a first-name basis. He was an Italian who lived from 1564 to 1642. He was good at physics, math, astronomy, engineering, and philosophy. He was best known for his studies of motion and of astronomy, and for driving the top dogs in the Catholic Church up the wall. He gets his own chapter in this book because he also believed in atoms and because he did science correctly. He had a lot to do with putting scientific investigation on the right track. Galileo took careful measurements and repeated his experiments. Whenever possible, he used mathematics to back up his conclusions. He took careful notes and explained his procedures. This all sounds like the obvious way to do experiments, but actually he was one of the few people at the time who knew how to carry out a valid experiment. The alchemists, remember, usually kept their lab notes secret. Here's a picture of Galileo's telescope. He paid extra for the fancy gold decorations. These were all new ideas, some of which made some people very annoyed. Unfortunately for Galileo, some of the annoyed people were very powerful. One of these was the Pope, who is the head of the Catholic Church. In those days, in Italy, you pretty much had to be Catholic, and the Pope had the last word on how to be Catholic. The discoveries about motion and about the solar system were backed up by reproducible measurements and observations, and are now accepted facts and laws of nature. We should take a closer look at Galileo's discoveries about moving objects, because motion of matter is related to a property of matter. That property is called mass, which is a measure of how much stuff is in something. The mass in one thing is attracted to the mass and another thing by a force called gravity. Gravity is a very weak force which can't even be noticed unless one of the things has a lot of mass. When the thing with the big mass is the planet Earth, the force is called weight. Please pound this into your head. Mass is how much stuff is in something, and weight is the force of gravity pulling that mass towards the Earth. Many people have been confused about mass and weight and how they affect the motion of objects. Galileo's experiments showed that Aristotle was one of the confused people. Aristotle thought that heavy objects fell faster. He also thought things in motion needed to have a force pushing on them, or they would slow down and stop. Wrong and wrong. It was very bold of Galileo to question the wisdom of Aristotle. In those days, a lot of scientific ideas were based on what highly respected authorities from the past had to say. Like Paracelsus, Galileo was ahead of his time in understanding that a good experiment trumps the opinion of some beloved old sage from ancient times. And in general, reaction to Galileo's criticism of Aristotle was, well, haven't you got a lot of nerve? It has been said that Galileo dropped things from the Leaning Tower of Pisa to show that all things fall with the same acceleration. It probably isn't true that he used the famous tower, but let's go with it because it's more picturesque than his actual experiment. You can prove Aristotle wrong with a simple thought experiment. Imagine you convince a 10,000-pound elephant and a 10-pound cat to climb to the top of the Leaning Tower of Pisa and jump off at the same time, into a net, of course. Would the elephant accelerate 1,000 times faster than the cat? Here's a picture of tourists fooling around at the Leaning Tower of Pisa and showing that there are basically two kinds of people in the world. But if weight is the force that causes falling things to accelerate, why doesn't more weight cause greater acceleration? The answer is that the greater force is spread out over a greater mass. Picture two skydivers with a total weight of 300 pounds holding hands as they fall. If they release their hands, there are now two falling objects that weigh 150 pounds each, but there is no change in their acceleration. As we mentioned, Galileo also showed that it is friction and air resistance that cause moving things to slow down. Without a force working against motion, moving things just keep moving. Moving things don't slow down because things would just naturally rather stop and catch their breath. This is also because of mass. Mass causes something called inertia. Inertia is a resistance to change in motion. It is hard to get out of bed in the morning, and it is hard to stop a charging rhinoceros because of inertia. Finally, a very interesting thing about mass, we can measure the mass of a thing by measuring its weight, and we can measure the mass of a thing by measuring its inertia. Even though weight and inertia are apparently unrelated, measuring either one gives the same mass, and no one really knows why. Galileo also made some excellent hypotheses about the nature of matter that are closer to the subject of this book. For example, he was one of the first scientists since the ancient Greeks to propose that stuff is all made out of atoms. Galileo based his belief in atoms on observations of everyday events. He thought correctly that atoms explained how we smell and taste things. His explanation of how these senses work is amazingly close to how we would explain them today. His term for atoms translates into something like smallest particles. He thought that some materials can break down into these particles, some of which are heavier than air and some lighter. The light ones move up and find their way into our noses and onto our tongues. This is a very good description of evaporation. He said these little bits could have different shapes that cause different tastes and smells when they come in contact with the little bits of matter in our nose and on our tongue. That is really very close to what happens. He made some wrong guesses too. He thought that atoms are separated by empty space, that is, by vacuums, which is true. However, he thought it was the suction of these vacuums that held atoms together, which is not true. He also thought incorrectly that atoms were just points with no volume. We can forgive him this mistake because he liked math, and a point is a mathematical concept. Galileo made an interesting observation about the classification of properties. He divided properties into what we now call primary and secondary properties. Primary properties such as density, hardness, and melting point belong to the materials and do not depend on our experience. Secondary properties are in our mind, such as color and smell. You might say, for example, that grass is only green when we look at it. One day in 1632, Galileo heard a knock on the door. He opened the door to see a church official who told him he had been accused of writing things that did not agree with the teachings of the Catholic Church. He would have to travel to Rome and stand trial to defend himself. A brief account of his trial is included here because it is the most famous example of problems that arise when scientific evidence does not agree with strongly held beliefs. The Church had been suspecting Galileo, thinking that the Earth wasn't the center of the solar system and that it actually traveled around the sun. He was ordered to stop thinking that. This is kind of like someone telling you not to think of an elephant. All his books were banned, and he was told that if he wrote any more books, they would be banned too. But he did write a book that presented the sun-centered solar system as just a hypothesis. They said that broke the rule and that he had to stand trial. He was tried by 10 people called inquisitors, and the trial was called an inquisition. It went on a long time and consisted partly of Galileo stating scientific observations and measurements, and the inquisitors quoting the Bible. They decided he was guilty and that they could burn him at the stake, or he could confess. They showed him devices that might persuade him to confess. You really don't want to hear a description of those devices. Here's a picture of Galileo at his trial. The inquisitor is saying, "Are you sure you're not thinking the Earth goes around the sun?" And Galileo says, No, I have definitely stopped thinking that. He had a hard decision to make. He could say what he believed and become a martyr for science, or he could lie and go on with his work. It is believed that he reasoned this way. If I lie, people might realize I was just trying to save my butt. Eventually, one of my books will find its way to a part of Europe that isn't Catholic, and someone will publish it. In time, the book will convince everyone of the truth. And that was what happened. So he told the inquisitors he truly believed that the Earth did not move and was the center of everything. He said he would never think that again or write it or teach it. And they let him off easy. They sentenced him to life in prison, but said that he could serve his time, never leaving his house, what today we call house arrest. In other words, he was grounded for life. Luckily, he had a really nice house. Here's a picture of Galileo's house, where he was grounded for life. It is thought that the sentence was a compromise between inquisitors who admired Galileo and those who wanted to roast him. They could have tried him for his ideas about atoms, which would have been an automatic death sentence, but they chose the lesser offense. Here is why being an atomist was so bad. When Christians perform the ceremony called communion, they eat a little piece of bread and drink a sip of wine. The belief is that the bread and the wine are actually transformed into the body and blood of Christ. This is called transubstantiation. No one could see how that could work if the bread and the wine were made of atoms. Casting doubt on this very sacred idea gets you in much deeper trouble than challenging the Church's ideas about astronomy. Isn't this a lot like the reaction to the ideas of the Greek atomists? It'd be clear that Galileo was not some sort of rebel who was trying to reform the Church and upset the world order. In fact, he was a devout Catholic his whole life. He also went as far as he could to reconcile his scientific findings with the Bible and the beliefs required by the Church. For example, he said that the bread and wine used in communion must be somehow different from other matter. He said that when the science contradicted the Bible, they were both correct, but the Bible passage was not intended to be taken literally. He said there were no mistakes in the Bible, but mistakes in interpretation. 100 years after Galileo's death, his remains were moved from a basement to a nice cemetery plot. 200 years after his death, the church unbanned his books. 250 years after his death, the church released the secret records of the trial. 350 years after his death, in 1992, the church apologized, sort of. The Pope admitted that mistakes were made, but he never said that the church was wrong to find Galileo guilty. Many people see the world as they think it should be, not as it is. Scientists must try to not even think how things should be, and must try to discover how things are and accept it. Scientists must always be able to change their mind when new evidence pops up. Fortunately, people who reject scientific results rather than change their beliefs don't often get to be scientists. Do you see any examples of strong beliefs in conflict with scientific findings today? Which side would you put your money on? That's the end of chapter 4. Chapter 5, which I'll post sometime before too long, is titled Newton, or Isaac Newton Discovers Apples. If you reduce the size of the YouTube screen so that you can scroll down, you'll see a link to a place where you can buy the book, read reviews, and so forth. If you see a subscribe button on the screen and click it, you'll be able to subscribe to my YouTube channel. I haven't been able to get the button to work yet, but it should show up at some point. Thank you. Goodbye.